Hi there, welcome back to this channel. In this video, we're going to be discussing limits. It's going to be our third video in the Precalculus series. You see, limits is a very important topic that you must understand in order to have a good grasp of calculus. You really need to understand limits and continuity actually. So, but this video is solely about limits. Now, you see, informally speaking, limits. The word limit means a particular boundary beyond which something cannot go, or a particular point where something will get to and will go no further. All right? So that is what a limit is. Now, if we talk about limits in mathematics, a limit is a particular number, a particular constant number, in which a function approaches and can never go beyond, or a particular constant which a function gets closer and closer and closer to as much as possible to and will not go beyond. Is that okay? So sometimes it means that sometimes a function can attain a limit and will never go beyond it actually, or it only can just approach it. That is, cannot go beyond, cannot really attain it. Is that okay? So it is either that a function can attain the limit or can only approach the limit, cannot attain it. Is that okay? So those are the possible conditions we might have. Now let's talk about the mathematical notation. Now you see a limit, if I say a limit is a particular L value, for example. So if I say, for example, this is the way it is read. Limit as x tends to a particular number, let's say a, particular a of my f of x function is equal to L. It means that L is that number that my function always approaches as x approaches 8, as x approaches a, and will never go beyond this. That is, the limit of this function as x approaches a is this L. Is that okay? So it could mean, for example, let's consider a quadratic function, for example. I could have limits as x tends to, of this quadratic function, as x tends to, let's say 2, for example, or 3, 2. So what is the limit of this function as x tends to 2? The limit of this function is 4. What does this mean? It means that as x approaches 2, as x gets closer and closer to 2, what your function approaches is x squared is 4. So since our function, since f of x here is x squared, then the limit of that function is 4. That is, x will not go beyond, the function will not go beyond 4 as x approaches 2. And what does that mean? Now, the idea is simple. There is what we call the right-hand limit and the left-hand limit. I'm going to talk about why this is very important in a jiffy. But first, let's understand what right-hand limit and left-hand limit is. So we have the right-hand limit and we have the left-hand limit. So the right-hand limit simply means when we go from the top to the bottom, that is, numbers that are greater than that number that we are talking about, but they are very close to it. So as we tend towards that number from the top, that is our right-hand limit. Now, don't be bemused as to why it is said to be right and not upper limit or something like that. It is used, right-hand limit is used because we always consider it, since it's on the x-axis, we always consider it as like a number line. So numbers that are greater than that number we're talking about, say 2, for example, numbers are greater than 2. So as we tend towards that number, we'll call it the right-hand limit. And as we tend towards that number from the left-hand, we'll call it the left-hand limit. All right. So let's talk about the right-hand limit. The right-hand limit is written this way. So if I say the limit of that my function as x tends to 2, from the right hand, we'll put a plus on top. This is not 2 raised to power plus. This is just 2 superscript. Plus meaning that the limit of our function as x approaches 2 from the right-hand side, and the left-hand limit is going to be the limit as x approaches 2 from the left-hand side of our x squared function. Is that okay? So, and these values are actually very important. So, for example, Let's first approach it from the negative angle. If we approach from the negative angle, let's separate from the negative angle. From negative angle means the numbers that are below 2 but are very, very much close to 2. For example, we have 1.9. That's the farthest from 2 as far as this condition is concerned. Now, 1.9 is the farthest. So we can have 1.999, 1.9999, 1.9999, 9 to infinity that way. So as you tend towards 2 and 2, so you see that this number is closer to 2 than this is closer to 2 than this, and so on and so forth. Is that okay? So as we tend towards 2, 10 closer to 2, for example, if we squared this number, we would get something around 3.61. If we square this one, we're going to get something greater than this, about 3.7 or 3.8. But notice that these values, all the values that we are going to get, are going to be approximately 4, approximately 4, approximately 4 in all the cases until we get to 3.9. So all the numbers we are going to get are going to be approximately 4. We're going to get numbers that will give us 3.999 something. Is that okay? So as a square all of them. That's what I mean now. So it means that we are approaching 2 from the negative side, from the side numbers that are below 2. So that is what we have here. Then for this side, numbers that are greater than 2. If we approach 2 from the numbers that are greater than 2, we're going to have this. We're going to have numbers like 2.1. This is the farthest from numbers that are greater than 2. For example, as this condition warrants, we have 2.01. This is closer to 2 than this, while this, in fact, is closer to 2, and this is closer, and like that, 2.000001. So even to infinity, is that okay? So those ones tend to be closer to 2 than these ones. Do you get it? So as you approach 2, as you approach 2, as you are closer to 2, the number that these functions are taking are approximately equal to what? 4. Do you understand? So 2.1 squared will give us 4.41. So this is approximately 4 actually. So, but as you tend towards to this downward direction, you're going to see that the numbers are going to be closer and closer. We're going to get things like 4.2, 4.001, 4.0000. So those are numbers that are approximately 4. So that's what we have here, that the number is going to be, function is going to ultimately approach our number 4. So that is the meaning of limit. Now, let's talk about the significance of this right hand and left hand limit. So why is it important? When we approach from the right hand, we get 4. The function approaches 4. And when we approach from the left hand, the function still approaches 4. Why is it important to now have the left hand and the right hand? And this is the reason. There are certain functions that when you approach from both sides, you do not get the same answer. So that is why this is very important, right hand, left hand. Now, let me give you an example of such a function. I'm going to talk about such more other functions. Well, the very typical example is the piecewise function. Now, let's take this function for example. If f of x is 1 over x, is that okay? So if our function is 1 over x, it therefore means that the limit of our function 1 over x as x approaches 0. Let's take this limit. The limit of our function of 1 over x as x approaches 0, or the limit as x approaches 0 of 1 over x. Those are the two possible ways you can read it. Now, what does this function approach as x approaches 0? Now, if you were just to come here and plug in the value of 0, you know that this function will be undefined. The expression you will get, or you will come out with, will be undefined. So how do we not get unreasonable answer? So how about we take the limit. We cannot just plug in. So it means that here x cannot be 0. But we have to resolve this. What does this thing, what is it tending towards? What is it tending towards? So you have to ask now, is it from the right hand side or from the left hand side? Now if it were to approach from the right hand side, we'll say plus, right? The limit as x approaches 0 of 1 over x from the right hand side. So what does this mean? It means that if we plug in values that are close to 0 but are a little greater than 0. For example, we have 0.1, 0.1, 0.01, 0.001, 0.00001, 0.00001, and so on and so forth until we have even infinity number of zeros. Is that okay? So if we plug in this value, 0.1 into this place, we're going to have 10, right? So we're going to have 10 here. If we plug in this value here, what are we going to have? 100. Plug in this value here, we have 1,000. Here, 10,000, 100,000, and like that. So we see that the number keeps increasing as our x value approaches 0, as our x value becomes smaller and smaller and becomes 0. So I will see that our function is becoming greater and greater. So, and it's on the positive side, right? So definitely there will be a time where we approach infinity, positive infinity, isn't it? All right. So how about we approach this limit, this function, from the negative side? So we'll say that the limit as x approaches 0 from the negative side of 1 over x. So what is the limit of this function when this guy approaches 0 from the negative side? What's the negative side now? Because 0 is the midway between positive number and negative number. You know, here we approach, this will be our 1, this will be 2, and this will be minus 1, this will be 2, and like that. And what we did here was just to pick from 0.1 towards 0. Here we're going to pick from negative now towards 0. Is that okay? So let's approach 0 from the negative side. So how do we approach 0 from negative side? We're going to have, if we divided, if we took x to be minus 0.1, or minus 0.01, or minus 0.001, or minus 0.00001, or minus 0.0000001, and like that, on and on and on and on like that as we keep approaching 0. What you will notice here is this. The same thing is going to apply. We're going to have over minus 0.1, and then we have 10 here. But it is because of the negative, it's going to be negative 10. Definitely here to be negative 100. Here will be negative 1,000. Here will be negative about 100,000 or even a million. Here negative 10 million and so on and so forth. So what did you notice? Here we're going to continue infinitesimally. Infinitesimally means as small as possible. And that is why the concept of calculus is called infinitesimal calculus. So it means when we deal with the calculations having to do with very tiny numbers. So these are very almost incalculable numbers. So if we continually approach that 0 infinitesimally from the negative side, we're going to eventually approach negative infinity. So what do you see here? When we approach from the positive side, we got a positive infinity. And when we approach from the negative side, we got a what? A negative infinity. So you see why it is possible, why it is important to take a right-hand limit and a left-hand limit, because we can approach different values considering the side from which we are approaching our value. So that is the use of the right-hand and left-hand limits. Now let's talk about the properties of limits. And these properties are the rules that every limit, that limits, follow, the rules that limits follow. So these are the, we call them properties of limits because they are constant for all limits that exist, limits that do exist, all right? So we have the first property, the properties of limits. They are basically algebraic properties. Is that okay? So it's not anything that big. Okay, now for example, the first one says the limit as x approaches a particular number a, for example, of f of x of a constant. Let's take for that of a constant first. Is going to be that constant. The limit as x approaches a of a constant is going to be equal to that constant. And why is it so? It is so because, okay, I think the light is dim. Now this is so. This condition is true because our limit, the limit we are taking is the limit of a constant. A constant has no x value. So because of that, whether this is approaching a or not, constant remains a constant. So for example, if I have limit of 2 as x approaches 1. 2 it doesn't have x, so you cannot even substitute value of x into that equation. Or, for example, look at that question I just said. The limit of 2 as x approaches 1 is still 2. How? Because the coefficient of the power of x here is 0. So x raised to the power 0 is 1, right? I mean, even if we were to plug in 1 here, so we have 2 into bracket 1 raised to the power 0. 1 raised to the power 0 is 1. 2 times 1 is what? 2. So you see, it's still that constant we are getting back. So the limit as x approaches any value of a constant is that constant itself. And the next rule says the limit of f of x as x approaches a of f of x plus the limit of f of x plus g of x, for example. So this is like the addition of a function, and it could be many other functions. It might not be just 2, g of x plus h of x, dot, 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 like that. You understand? So if we have many more functions like that, this rule says that the limit of this function should be equal to the sum of the individual limits of each function. So it should be equal to the limit as x approaches a of f of x plus the limit of g of x as x approaches a plus the limit of h of x as x approaches a. So the sum of the limit of a sum of function, the limit of the summation of a function is equal to the summation of the individual limits. All right. Then number 3 also says that the limit as x approaches a of f of x minus g of x should be equal to the same way, be equal to the limit as x approaches a of f of x minus the limit as x approaches a of g of x. So the limit of the difference of a function should be equal to the limit to the difference between the individual limits. Then number 4 says the limit as x approaches a of f of x times g of x times h of x, continuous like that, is going to be equal to the limit of, now we're going to quickly prove this three because just to show you that it actually exists, or that those these properties are actually true, times the limit as x approaches a of g of x. So let's quickly prove from rule 2. This rule says that the limit of f of x. So if I said, let's say our f of x is x plus 2, and g of x is 3x minus 1, and h of x is x squared plus 2. So that this first rule says that the limit as x approaches a of f of x plus that plus that plus that should be the same as the sum of the limits. So let's use that first. So what would this first one give us? If we say the limit as x, if we take the limit as x approaches, say 2, for example. So if we take the limit, just the addition of all of this, addition of this will give us 4x. So x squared, the limit x squared plus 4x, 2 plus 2, 4 minus 1, 5. So this is the addition of the functions. Is that okay? I just added it and I got this. So if I have limit, if I take the limit, now since the direction is not given, it means both right hand and left hand limits will attain the same value. Is that okay? That's very possible. So, and we've proven that before. So as x approaches 2, it's going to be 2 squared plus 4 into brackets 2 minus 5. I'm going to have 2 squared is what? 4 plus 4 times 2, 8 minus 5. This plus this, 12 minus this is 7. And that is the answer for that. Now, let's now take the limit of each of the functions as x approaches 2. So the limit of the first function, the limit of f of x as x approaches 2 is going to be 2 plus 2, that's 4. The limit of f of x is going to be 4. Limit as x approaches 2 of g of x is going to be, we plug 2 into here, it becomes 6 minus 1, 5. Then the limit also as x approaches 2 of h of x. These are h of x. We plug 2 into the equation, it becomes 4. 2 squared, 4 plus 2, 6. So let's add this all up. We are supposed to get the same answer. Okay, but it doesn't seem like we're getting the same answer, right? Okay, this times 2 is, this times 2, 6 minus 1, 5, plus 2. Oh, okay, sorry. This plus this is 4. 4 minus 1 is 3. Here is 3. Here is 3. So this is 3. Here is 3. This was this 12 minus 3. That's 9. Is that okay? That's 9. And this is 2 times this 8. Alright. I think that's correct now. So let's take this again. So 4 plus 6, that's 9. Plus h of x. Let's verify this again. The limit is x squared plus this minus, no, that's supposed to be plus, come on, that's plus, as in 3 plus 2, 2 plus 2, or 2 minus 1, 1 plus this is 3, so plus, so 12 plus 3 is 15, I'm sorry, when you shoot on camera sometimes you have this kind of mistakes, so I think we are now correct. This plus this, 10 plus this, 15. You see that? So the rule stands. The rule stands. Now we can also try that for this. The limit, if we subtract two functions from each other, let's subtract this from this. So that will be x minus x plus 2 minus 3x minus 1. So that becomes x plus 2 minus 3x plus 1. So this becomes minus 2x. And here we have 3. So 3 minus 2x. So if we take limit as x tends to 2 of this function, we're going to have 3 minus 2 times 2, 4. That is minus 1. Let's now take the limit of the individual functions. So limit of this gave us 4. Limit of this gave us 5. So if we take 4 minus 5, that gives us minus 1. So you see, this second rule also holds. All right. If we take f of x times this, you can also prove this on your own. But it surely stands. Is that okay? It surely stands. All right. Then the fifth rule is, this is a product. Let's talk about the quotient rule. The limit as x tends to a of f of x divided by g of x is the same as, should be equal to the limit as x tends to a of f of x over the limit as x tends to a of g of x. Is that okay? So that also holds. The other one is that the limit of k times f of x should, as x tends to a, should be equal to k, that constant, times the limit of that function alone, as x tends to our a. Now these are the rules of the limits, or the properties of limits. In the next video, we are going to be discussing the 3 methods of solving, 3 most common methods of solving limits, of evaluating limits, and it's very simple. They're very simple, but you see, because of the number of complex, there are some complex questions that we're going to be attempting. So we're going to see how I'm going to simplify. We're going to be evaluating limits in the next video. We're going to be talking about the factorization method, the direct substitution method, and the method of we just have about 3 methods like that we're going to be discussing, including L'Hospital's rule. So Alright, so that will be it for this video. Do well to subscribe to the channel and make sure you stay tuned for that next video because we are going to be solving many questions, many variations, and I'm also going to be releasing a trick at the end of the video. So make sure you watch that video till the end. See you in the next video. God bless you. And subscribe to the channel if you have not already, and share the content with your friends.